everyone, my name is Hemu and today's we are going to discuss one of the most important topic which is DNS. So in this particular session I will basically try to cover everything with regards to DNS. And if you know, in most of the interviews people like ask like what is DNS, what is DNS records, how DNS works, can you just explain in detail, right? So all these things we are going to see with practicals. I'll take the Wireshark captures and everything we will see. And for this particular training or this particular session, I am going to use this particular lab where you can see I have my layer 2 environment where I have couple of test PCs. We have a like these PCs are on VLAN 20. We have a this PC on VLAN 30. This is my local DNS server on VLAN 10. Then I have my core switch. Then I have my Palo Alto firewall, and after that I have a connectivity with the internet. In internet we have like root DNS server, com DNS server, Facebook DNS server, right? Then this is your Facebook mail server, then your Facebook web server, right? How the communication used to happen, everything we are going to discuss basically regarding that. So this is the lab topology which I'm going to use for this particular lab, guys. Okay, so now let me start with your DNS. So first of all, if somebody asking like what is DNS in your in interview, so what do you have to do? You have to explain like DNS stand for domain name system, and the main job of this particular DNS is to basically what DNS used to do. It basically translate the domain name with the IP address, and also we can basically translate the we can also translate IP address with the domain name. So both things can be possible, right? So DNS provides TCP/IP name resolution service, which is the process of translating host and domain names into their corresponding IP address and vice versa. And guys, let me tell you one more thing. Let's suppose in internet we have a multiple website. We have a google.com, we have a facebook.com, we have a gmail.com, we have a webex, zoom, like there are multiple web servers are available, multiple mail servers are available, right? And when you are accessing these servers, are you going to remember their IP address? No, we cannot able to remember the IP address, but domain name we can remember. We can remember like google.com, facebook.com, icicibank.com, sdfcbank.com, right? This IP address, to remember this IP address, it's very difficult, guys. It's a very difficult thing to remember it. Okay, so what we used to do, we used to remember these domain names. Now when your traffic will, when we initiate any traffic towards, let's suppose this domain, or let's suppose towards facebook.com, what will happen that time? When your layer 3 packet is constructed, that time we need the destination IP address of that particular domain. And how we will get that destination IP address? We will get that destination IP with the help of DNS. DNS is the protocol who will provide us that particular detail. And guys, your DNS is a application layer protocol, and DNS generally works on TCP port 53 and UDP port 53. So these are the port number of your DNS. Okay, now let's see the other detail. When we want to access a server on internet like Facebook, Google, etc., we need to know the server IP address. Whenever you are accessing any server over the internet, we need that IP address, because you know, without IP address we cannot able to construct the packet, right? As humans, we are used to address entities using names, not their address, right? For example, if we want to go to a city, we will use the name of the city, not its postal address or zip code, right? We are not going to use his pin code or postal address, right? We are going to use the name of that city. It's a similar thing. Like in internet, whatever the web servers are available, we always, if we want to access them, we have to basically remember the fully qualified domain name of that particular web server. But the internet communication are based on addresses, so a mechanism was designed to make it easier for users to access the resources over the internet, and that particular mechanism is basically carried out by the DNS, domain name server. This is the protocol. The companies had to register a domain name in addition to acquiring an IP address range from the ISP. The company would then assign the servers a name in addition to unique IP address. Let's suppose you are trying to access SIANETS.com, right? So what, when we have purchased that website SIANETS.com, that time we have basically purchased this particular domain. We have purchased that domain from our service provider or from our domain provider. Like we have purchased that website from GoDaddy. The users could refer to the server using its name rather than the IP address. A server known as the domain name server was designed to provide the resolution between the name of the device to its IP address. Each domain would have its own DNS server that would do the name resolution for that particular domain or that particular company devices. The users could refer to the server using its name rather than the IP address. A server known as the domain name server was designed to provide the name resolution between the IP and this. Each domain would have its own DNS server. The IP address of the DNS or name server for the domains and on the root DNS server. So guys, we have a something called root DNS server. I'm going to discuss that part as well. Okay. So this is the same definition. So I'm not going through with that. This is also a like DNS is an application layer protocol. It works on TCP UDP on port 53. And port 53 is the standard port, guys. A standard DNS queries and response typically use UDP. TCP is used for the DNS message greater than 512 bytes. If your message is greater than 512 bytes, what we are going to use TCP 53. In normal case, we will use the UDP 53. In either case, port 53 is going to use for DNS. Now let's try to understand the DNS server hierarchy. So maybe in your interview, they will ask, can you just explain the DNS server hierarchy? In that hierarchy, you have to know what is root DNS server, what is top level domain, yeah, like TLD server, then what is the authoritative name server. So now let's try to understand that part. So generally what used to happen, guys, if I'll go into my whiteboard, if I will go here into this DNS hierarchy section, so when we will try, if you want to try to understand this DNS hierarchy, before that, let me just explain you something regarding the fully qualified domain name or FQDN. So our FQDN is used to uniquely identify a host on the internet, such as my website like www.instructor.com, or composed of for 3 components. So generally, let's suppose if I will type at www.sianets.com. In this www is known as a host name. Then we have a sianets.com is the domain name. And here we have a top level domain is com. And guys, let me tell you one more thing here. Every website, like if I will just say here, like sianets.com, and there is a one dot is always available at the end, guys. This dot denotes the root DNS server. Then we have a com DNS server. This is your top level domain. Then this is your domain server. So that's how these particular hierarchy is divided. If I'll go into this diagram, you will able to see the hierarchy. In DNS hierarchy, if you will see, first we have a root DNS server, which is denoted by the dot, like www.sianets.com. Then we have a dot. So this dot is basically denoting the root DNS server. And guys, across the globe, we are having around 13 root DNS server. What we have a 13 root DNS server across the globe. And after that, we have a top level domain like your com DNS, your mail, education, edu, net, org, like country related domain like n, .jp. All these are the country specific, or your all these belongs to the top level domains. And after that we have a second top level domains which is like a microsoft.com. Maybe we have a like Microsoft domain there. And after that we have a third level domain like technet.microsoft.com. So like that we have a hierarchy, means on the top we have a root DNS server, then we have a com edu net org, and after that we have a website specific domains like a Microsoft, Facebook, Google, all of them. Then we have a other domains like we can say mail.google.com. All these comes under this third level domain. So like on top we have a root DNS server, then we have a com DNS server, org DNS server, edu DNS server, Yahoo DNS servers, amazon.com, like pvs.org, poly.edu, right, unmesh.edu. Like these are the some low level domains actually. So this is how the DNS hierarchy available in the environment. If you can see here, your dot is always denoting the root DNS server. Then we have a .uk, .au, .com, .cx, .net, .org, right? And after that we have a cisco.com, microsoft.com. Then we have a support.microsoft.com, support.cisco.com, because this is the end domain. And guys, let me tell you one thing, this root DNS, this DNS, let's suppose microsoft.com DNS is managed by the Microsoft. Cisco.com DNS is managed by the Cisco.com, and this root DNS is managed by the INA. INA is responsible for management of these particular DNS. Now let me just see what I have apart from this, and after that we will go one by one. Let me decrease the size here. The most important thing, guys, if you go here, so this is how your DNS server is basically distributed across the globe. That's how, like, all your 13 root DNS server is distributed across the globe like that. And we have a total of 13 root DNS server. And if you want to see the detail, or before showing into the detail, what I can do, these are the root DNS server, guys, which I was mentioning. These are the 13 root DNS server. These are the 13 root DNS server available across the globe with their IP address and other thing. Okay. Let's back to the notepad now. So root DNS server, like root DNS server is the first entity which is contacted by the local name server or local DNS server that cannot resolve the name. Let's suppose if your local DNS server is not able to resolve the name, in that case what it will basically contact with your root DNS server. Contact authoritative name server if name mapping not known, get the mapping and return mapping to the local name server. And across the globe we have a 13 root DNS server, guys, just remember. And these are the command. What you have to do, you have to go to into your command prompt. So let me just do that. Let me open my command prompt. In this command prompt, what you have to type, you have to type ns lookup. So you will able to see this is my ISP DNS server. Now I'll just type this command set type equals to name server. Then what I want to see the details for com. So I will just type here dot. So let's say I want to see the detail for root. So I will just type here dot and you will get the details here. These are your 13 root DNS server. You can count. The number is 13. 4, 8, 12 and 13. So these are the 13 DNS server, root DNS server spread across the globe. And at the same time, if you want to see the detail of com DNS server, you can type here com, you will get the com DNS server detail as well. If you want to see the org DNS server detail, you can type, you will get the org DNS server detail. If you want to type like in, you will get able to see in DNS server. You can type JP, which is for Japan, you will see Japan DNS server. You can type edu, you will get the edu related DNS servers. Type here, like you can type anything. Let me just type here Facebook. This is the for Facebook, we don't have any DNS server. Maybe the name is different for Facebook. Let me try for Gmail. These are the Gmail name servers basically. So you will be able to get all the detail. Let me just type for Google. These are the Google DNS servers. Okay. So like that you can able to see. Let me just type here SIANETS. We don't have any DNS server for SIANETS.com. Okay. So whatever the website, if you will type here UK, you will get all the DNS server for UK websites. The website which is ending with UK, like www.abc.uk.uk, www.xyz.uk, right? So these are the DNS servers who is going to provide the detail. These are the top level domains for that. This TLD responsible for com, org, net, edu, etc, and all top level countries, UK, FR, CA, JP. Means TLD domain servers is responsible for maintaining all the records for these domains. Network solution maintains, so there's a company called Network Solution who maintains the com top level domain. All the com related websites domain is maintained by Network Solution. edu cause is responsible for managing your edu top level DNS or TLD server, TLD DNS server. And after that we have a one more term here, like authoritative name server. Authoritative name server, this is the name server which is managed by a particular organization, right? Organization DNS servers providing authoritative host name to mapping for the organization servers like web, mail, app can be maintained by organization or service provider. And most of the time these type of DNS server is maintained by the organization, guys. These are the organized maintained domain. Let me just give you the example. Like if I'll say, if I'll just type here supports.facebook.com, we have one, then we have a messenger.facebook.com, then we have a www.facebook.com. like all these particular domains is maintained by the Facebook DNS server, and that DNS server is known as authoritative DNS server. And then how these root DNS server, your top level domains, your authoritative name server, they comes in a picture. So when I'm going to explain you how the things happening, how the traffic flow for DNS, that time you will able to get all the things. And there is a one more term called local name server or local DNS server. So does not strictly belongs to the hierarchy. Each ISP or residential ISP or company or university has one. Like we are from the SIANETS.com, like in my lab, I have my local DNS server, which is this one, where I will host my local servers. Let's say this is my local DNS server. So what I will host here, like global protect gp.lab.local, then portal.lab.local, then mail.lab.local. Like that we can create a multiple domains as well. This is for locally only, guys. And this DNS server will resolve the query for your local, for your internal systems. Now guys, let's try to understand. In DNS, we have to understand two things. DNS query. So guys, we have a two type of queries, iterative query and recursive query. And we have a DNS response. When we will send the query, we will get the DNS response. Okay. So guys, now what I can do, I'll go here. Now let me just explain you the DNS queries first, how the things happening. So the first type of query is known as a iterative DNS query. In iterative DNS query, what used to happen? Let's suppose on this computer, I have typed, I want to access www.facebook.com. When I will type this URL into the browser of that system, what it will do? The very first thing which this particular PC will do, it do the DNS resolution. It will do the DNS resolution for that particular website. So what it used to happen? It will basically forward this request to local DNS server. That request is known as a DNS query. Means he will send the DNS query towards the local DNS server. Now what used to happen? Now this local DNS server basically do the query to the maybe public DNS server. Let's say this is your public DNS server. Let's suppose this public DNS server is not having that detail. It is not having the detail. So what it will do now, this local DNS server will do the query to root DNS server. Now root DNS server send the reply. Let's say we are accessing facebook.com. So this root DNS server will provide the IP address of com DNS server. And now it will send that request to the com DNS server. Now this com DNS server will send the reply of the Facebook DNS server. And after that, that particular local DNS server needs to do the query to Facebook DNS server, and from here it will get the detail of facebook.com. Means it will get the IP address which is basically associated with facebook.com, and after that this local DNS server will provide that IP to this particular PC, and now this PC will basically start the TCP three-way handshake with the Facebook server. Then it will go through with the SSL handshake, and now he will basically start communicating with that server. So guys, iterative query means what used to happen? This PC will forward this request to local DNS server. Now it's a responsibility of this local DNS server to basically communicate with the public DNS server, with the root DNS server, with the top level domain server, and basically provide the IP address. And what is the why we have this type of queries? Because iterative queries will help us to offload the load from root DNS server, from the com DNS server, or from the public DNS server, because all these queries are the iterative queries, and by default everything, all the DNS communication happening on the basis of iterative DNS queries, guys. Okay, if I'll go here, if you will see this flow, but before that let me explain you here. The local DNS server queries the root server if the address not in its database will have the name or address of the intermediate or authoritative name server or the top level DNS server. It will basically forward that information to the local DNS server so that it can directly communicate with the intermediate or authoritative name server. This is prevent the overloading of the root server that handles many millions of requests. And guys, you will able to understand this iterative DNS query. Let me explain you the recursive DNS query first, and after that I'll come back again. In recursive DNS query, what used to happen? From this PC, and now I'm trying to access Facebook again. He have forwarded this DNS query to local DNS server. Now this local DNS server have forwarded this request to the public DNS server. Now you can see now this public DNS server is sending this request to root DNS server, and he will ask, can you have the IP address of facebook.com? Now this root DNS server will communicate with the com DNS server, and after that this com DNS server will basically communicate with the Facebook DNS server, and once this Facebook DNS server will provide the IP address to COM DNS server. Now this COM DNS server reply to root DNS server. Now root DNS server will reply to public DNS server, and public DNS server will reply to local DNS server. And after that, this local DNS server will provide the IP address or reply as a DNS response to this particular PC. Now, if you will see here, in iterative queries, what used to happen when request is received by this public DNS server, he has just provided the IP address of root DNS server, right? You can see, but here he has communicated directly with the root DNS server. Now root DNS server needs to communicate with the COM, and after that COM needs to communicate with the Facebook DNS server. So what we are doing, we are basically adding lots of load on these particular DNS servers, which is wrong. Right? So guys, this recursive lookup is not good at all, because if we are doing the recursive DNS query, which means we are basically overloading your we are overloading your public DNS server, your root DNS server, your top level DNS servers, right? And because in iterative, your local DNS server is responsible for doing all the queries. Your local DNS server will communicate with the root DNS server. Now root DNS server just provide the IP address of COM DNS server. Now this local DNS server will communicate with the COM DNS server. Maybe you can able to understand from here. This is my PC, and from this PC I'm trying to access csc.nyu.edu. I have forwarded this request to local DNS server. Like, what is the IP address of dns.nyu.edu.com? This website, dns.nyu.edu. So what now? This particular local DNS server, he has forwarded the iterative query to root DNS server. And guys, this query, which is happening between your PC and your DNS server, is the recursive one. Till only this section is the recursive one, and after that everything is iterative. To root DNS server, because by end of the day we have a dot. Now this root DNS server will provide the IP address of edu DNS server. This is the edu top level domain. Now this local DNS server will communicate with the edu DNS server, and he will ask, can you just provide the IP address of csc.nyu.edu? So this edu DNS server will provide the IP address of nyu.com, authoritative DNS server. Now he will forward this request here, and this is the authoritative DNS server which is responsible, or which is having this particular website detail. So he will forward that, he will send the DNS response to local DNS server, and where it will provide the IP address, and after that this local DNS server will forward this request to your PC. So that's how the things happening. This is your iterative query. Recursive query means if you are sending recursive query towards root DNS server from local DNS server, which means now we are telling this root DNS server, I want IP address of I want IP address of csc.nyu.edu.com. Can you just provide that IP address? So now this local DNS server will send the recursive query to edu DNS server. Now edu DNS server will send the recursive query to nyu DNS server, and this server will provide the IP address to edu DNS server, then to root DNS server, then root DNS server provide the IP to local DNS server. That is your recursive lookup. And guys, we don't use recursive lookup in the production environment. Recursive lookup is only happening between PC and your local DNS server. So you can see here, the client machine sends a request to the local DNS server, which if it does not find the address in its database, sends a request to the root DNS server, which in turn will route the query to an intermediate DNS server or authoritative name server. Note that the root name server can contain some host name to the IP address mapping. The intermediate name server will always know who the authoritative name server for that particular website. That's how communication used to happen, guys. And one more thing, there are few more very interesting commands available, guys, in Windows machine. If you will run this command, ipconfig /all, here you can able to see. Let me just check the IP config details on my adapter, which is Ethernet adapter. This is my Ethernet adapter. This is the IP address of my system, subnet mask, DHCP detail, and my DNS server is 192.161.1. So you will able to see the DNS server detail. Apart from that, if you want to see what, you can run this command ns lookup, and if I will type here gmail.com, you can basically do the lookup. You will get gmail.com having two IP address. This is the IPv4 address and this is the IPv6 address. In similar way, you can go and you can type facebook.com. Here also you can able to see facebook.com having, this is the Facebook IP address and this is the IPv6 IP for facebook.com. So by using this ns lookup command, you can able to basically get the detail what is the IP address of that particular website, IPv4 and IPv6. Even though you can also initiate a ping tool, let me just do the ping to. Let me just do the ping to Amazon.in. See, I can get, this is the IP address of Amazon.com and ping is happening. So by doing the ping, by doing the ns lookup, we can able to get the domain to or name to IP mappings. IP config, the very important command, which is display DNS. If you will run this command, you can able to see that local DNS cache. Like we have this is your local DNS cache. Local DNS cache memory basically. And here you can able to see when we will try to access any website, these particular information is saved here into your local cache memory. Like we have like zoo updates.epicpen.com, multiple like porter.lab.local.com, firewall2.lab.local.com, gateway.lab.local.com, right? All these are the local DNS entries or local DNS cache which is managed by your PC. And this particular entries, they have a time to live, TTL value. These particular information used to expire after these many seconds. These are the values for that. Okay. And if you want to remove all these cache memory, what you can type ipconfig /flush DNS. What it will do, it will basically flush all your DNS entries. But it will again maintain some entries because you know communication is happening here, right? Communication is going on, that is the reason. But it will remove the details. And why it has these like gateway.lab.local, because you know these particular details I have updated into the local host files. That's why you can able to see. So this command ipconfig /flush DNS we will use to remove all the DNS entries. ipconfig /display DNS we will use for to check what is that basically things we are happening, like what are the DNS cache available into your system. Now let's try to understand how DNS works. The very important question, guys, how DNS works, because you know in your interview this is the question which is asked by the people. So what I will do, I will explain this question in two ways. First, I will use this PC and this diagram, and second I will use this, and where, because here I have mentioned IP and other things with this particular diagram. So now let's try to understand that part. What used to happen, guys? I have my test PC here, PC1. On this PC1, what I did, I have basically type a website called facebook.com. What? I've opened the web browser on this PC and I have typed facebook.com. When we type the facebook.com, this PC will do very first thing, which is DNS resolution. It will do the DNS resolution. When this PC do the DNS resolution, what it will do? Now, guys, you have to remember a few things. And these are the things which is most important from the interview perspective. What is the very first thing which you need to remember? When you will basically type this facebook.com into this PC, what this PC will do, the very first check which is done by this PC is it will check the local DNS cache. It will check the local DNS cache memory. And that particular cache memory, how you can able to see, you have to run this command ipconfig display DNS. This is the command for that. And let's suppose when we have typed local, when he had done the lookup into local DNS cache, and if let's suppose this PC have found the IP address of facebook.com into the local DNS cache, what it will do, it will basically get the IP address, and now it will start with the TCP/3 handshake with the facebook.com server. Let's suppose we are accessing this facebook.com on this PC very first time. So this particular facebook.com is not available into the local cache. And after that, it will do the lookup into the next check, which is known as a local host file. Local host file, every system have one host file. And let me just tell you where is that host file. So I'm just basically, I'm on my another screen. I'm just basically opening that local host file. And just give me 1 second. C drive. In C drive, I have to go into my Windows. What you have to do, you have to basically go into your C drive, then Windows. In Windows, you can have to look for System32. In System32, you have to look for etc. Where is this etc? Drivers, System32 drivers, then etc. Then we have this host file. And if you will open this host file, let me just open this host file with Notepad++. You can able to see this is the host file, and in this host file I have defined some local entries like xyz.com, firewall2.lab.local, Palo Alto firewall1lab.local. Like I have defined all these entries, so it will check this particular host file, guys. This is the one. And if you want to add your entry, you can basically add these entries as well. You have to open this file as an administrator. You can able to open. And this is the path: Windows, System32 drivers, then etc. There where we have a host file. And this is the next file which it is going to check. Local host file. And let's suppose this domain detail it has find into the local host file. What it will do, it will stop the DNS lookup. It will get the IP address, and it will basically start communicating with the Facebook server. Now the third thing, what it will do, now it will basically start communicating with the local DNS server. And what it will send one query. It will send one DNS query towards this local DNS server. This is the DNS query. And what type of query? It's a recursive query. It's a recursive DNS query. In this query, what he will ask, he will tell source IP address is 10.1.1.85 in this packet, and the destination IP address is 10.1.1.220. And he will ask what is the IP address of facebook.com. He simply asked this query to local DNS server. Now when this request reached to local DNS server, now this local DNS server have the record. In this local DNS server, it has the record. It has a record like it has some A record. A record we use for IP, like domain to IP mapping for IPv4. 4 time A we will use for mapping of the IPv6 address with the domain. Then it has some MX record, right? It has some PTR record, multiple type of record are there. That will check these records. And also it will check into the local, into this DNS also maintain the local cache. It will check this particular domain name facebook.com into its record and cache memory. If it will find the detail, what it will provide the facebook.com IP address to this particular PC as a DNS response. But let's suppose it's a first request and we are accessing, or like in your organization people are accessing this website first time, so we don't have any detail of facebook.com into this local DNS server. Now what it will do, now this local DNS server will start communicating with the public DNS server over the internet. And what it will do now, from this domain called facebook.com, then we have a dot at the end. This dot denotes the root DNS server. Then this com is responsible for top level domain, TLD DNS server. Then this is the final authoritative DNS server. Authoritative DNS server, which is maintained by the Facebook or maybe ISP of Facebook. What it will do now, this local DNS server will basically start communicating with the .DNS server. And what he will do, he will basically send a request to this particular .DNS server like that. He will send one query from here to this particular root DNS server. Now this root DNS server, what it will do, it will basically check what is the DNS query. He has sent the DNS query to get the IP address of facebook.com. Maybe he has asked the IP address of facebook.com. So now this root DNS server check his database facebook.com. If he is having the IP address of facebook.com, he will provide. Generally root DNS server will not have the IP address of facebook.com, but it has the IP address of your com DNS server, your edu DNS server, your in DNS server, your .jp DNS server, .org DNS server. So he will check facebook.com belongs to the com DNS server. So what he will do, he will reply to this local DNS server. In this reply, he will tell you can basically communicate with the com DNS server, and com DNS server IP address is this. And guys, this query is the iterative query. Just remember, this is the iterative query. Now what will happen? Let me just take a different color here. Let me take a black. Now this local DNS server will communicate with the com DNS server, top level domain. Now this com DNS server will also check his database. Is this DNS server, this com DNS server will check his database. He is having the facebook.com IP address. So he will check. He don't have the www.facebook.com IP address, but he know the IP address of the Facebook DNS server. What he know? He know the IP address of Facebook DNS server. So what he will do? He will basically go and he will type here, but he know the Facebook DNS server IP address, which is this. So what he will basically reply with he will reply to this local DNS server with the facebook.com DNS server IP address. Now this local DNS server, what he will do, he will basically send the query What he will do now, he will send this query. Now he will send this query to Facebook DNS server. Now, because you know this DNS server is the authoritative DNS server for facebook.com. So he should have the IP address of facebook.com. He know the facebook.com is hosted over 157.240.198.35. So what he will reply to this local DNS server. Facebook.com IP address is 150.240.198.35. This is the facebook.com IP address. So what it will do now, this local DNS server update his cache, like facebook.com IP address is this, and he will basically reply to this particular PC. He will send a DNS response here. On this response, he will tell facebook.com IP address is this. And once this PC get the IP address of facebook.com, so what he will do now, he will basically try to create a connection with the facebook.com, and he will forward this request towards the Facebook web server. And what request he will send, the TCP send request, which is the first packet in the communication. So guys, that's how the basic communication happens for DNS. Now let's try to understand the same process with this particular laptop logic, because this is the most important thing, guys. If you can able to understand this traffic flow, you are good to go. You are good to go with the things. So let's suppose what I am having. This is my local DNS server having IP address 10.1.1.220. This is one of the PC having IP address 20.1.1.150. And after that, we have a root DNS server. IP address is 151.7.100, 161.7.100, 171.7.100. Then this is your com DNS server. This is your Facebook DNS server. Then we have a Facebook mail server. Then we have a Facebook web server. So that's how things are available. So what now we have to do? So in this PC, what this PC did, on this PC, I have opened the web browser and I have typed facebook.com. So the very first thing which this PC needs to do is the DNS resolution, right? In this DNS resolution, when he will do, what he will do, he will send the very first request, and that request he will forward towards the local DNS server. And this is the recursive lookup. Now local DNS server, what he will do, as I have mentioned in previous as well, it will first check the local cache. It will check the host file. If he will not get the detail, then he will do the DNS query towards the local DNS server. Now, if we have the IP address of facebook.com with this local DNS server, then he will provide the detail. If he is not having that IP address, what he will do, now he will forward this request towards this root DNS server. And this is the iterative query. This is the iterative lookup. Now this root DNS server, he will basically check his database. Is he having the facebook.com IP address? Let me just write down the things here. He will basically, let's say we have access www.facebook.com. So what it will do now, he will check his database. Is he having the IP address of facebook.com? So he will check, like he is not having IP address facebook.com, but he will check his database. He has the IP address of com DNS server. So what he will do now, he will basically send the reply to this local DNS server. He will provide the IP address of 161.7.100, which is the com DNS server IP address. So here he will get, in reply, he will get the IP address of com DNS server, which is 161.7.100. Now what he will send that DNS query again towards this com DNS server. Com DNS server will also check his database. Is he having the detail of facebook.com? Generally the detail is not available. So what he will, but he will check, I don't have a facebook.com IP address, but I know the DNS server IP address of facebook.com, who is the authoritative DNS server for www.facebook.com, mail.facebook.com, support.facebook.com, messenger.facebook.com. All these type of hosts you will get into this particular DNS server. So in this reply, what he will do, when we will send the reply, in this reply he will get the IP address of 171.7.100. and once he had the IP, what he will do, now he will basically forward this the next query. Now this next query he will forward towards the Facebook DNS server like that. Now with this Facebook DNS server, because it has a record, it has a record for mail.facebook.com, support.facebook.com, Facebook, www.facebook.com, and www.facebook.com is 181.7.100, and he has the A record for that. So what he will basically reply, and he will reply to this local DNS. He will tell www.facebook.com is hosted on 181.7.100, and now this local DNS update its cache, and he will forward this request to PC. Now PC also update his cache, and he will basically start doing the communication over this IP address. He will send the TCP send request. That's how the DNS works in the production environment, guys. So all the queries which is initiated by local DNS server towards your root DNS server, com DNS server, or any authoritative DNS server, all are the iterative queries. And when your local system will do the query with your local DNS server, this is the recursive query. Okay. Now what I will do, I'll go here. I'll just start my captures on Wireshark. Let me just start the captures on the Wireshark. Remind me later. And I want to do the capture on my VMnet 1. Now, I also do one more thing. I'll go here and I will start the captures on this PC interface as well. VMnet 1, I have capturing the VMnet 1 traffic because VM1 is available here. This is my VMnet 1 only. Okay. Now I'll go into this Windows machine. Let's have a Wireshark captures and try to understand the things. IP config /all. Let me just see the IP details. VNCPH.cpl. I'll go into this PC and I have to configure the IP details on this PC. I'll go here and IP address on this PC I want to configure, which is 200. Not like that. 20.1.1.200. Default gateway is 20.1.1.1. My layer 3 switch, and the DNS server is 10.1.1.220. Go here, try to do one thing. Ping to 10.1.1.220. Check the ping is happening till DNS. We can able to see the packets like traffic coming from IP.addr equals 20 what happening actually 20.1.1.200. You can see some ping request, some DNS request is coming, right? And this also you can able to see some ping request right from this PC going towards DNS and other things. Now the best part is, now I'll go here into this PC, not this one, sorry, this is the wrong system I have opened. I have to open my test PC1. This is the one which I want to open. Let me just close this. Now I'll go here, and in this system, what I will type, because I just want to see the process for this. So I will go here, I will just type ping to flipkart.com, because this is the website which I have never accessed on this server or this PC. Type flipkart.com. Let's wait here. Now DNS and all these things will happen in a backend. Flipkart.com is not able to reach. Let me go into this Windows machine. This is my system. Let me just ping to google.com on this system. I'm not sure why this ping is not happening. Just give him some time, because it was working previously. Because I did some mistakes here during the configuration. I've configured the same IP address on one of my Windows machines. So that is the maybe reason. So I'll just wait here for some time. ipconfig ping to 10.1.1.100 is working. 220 is working. 250 is also working. Ping to 8.8.8. is also working. Means now ping to google.com is not happening. Why? It's happening, right? It happened. I'll go here. I'll go into my captures, and I'll just continue without saving, because I want a fresh capture here. This is on VMnet 1 and this is on my PC. Now I'll go into this PC, and this time I will type here the ping to cisco.com, hit enter. See who has a standard query. So cisco.com, right? It's still not able to get the cisco.com detail. Let me just do the things again. See, it got the IP address. Now ping is working. I'll stop this ping. I'll stop this capture. I'll go here, and I'll stop this captures as well. Now let's try to understand the things, guys. I'll go here into this particular capture which I have took at my PC end, and in this PC end, if you will see, let me just put the things like that. In this PC, what I did, let's start from here. 20.1.1.200 is the IP address of my PC. So from this PC, I have basically initiated a request, right? From this PC, I have initiated a request. I have just did the ping to cisco.com. So what he will do, because when he wants to ping to this cisco.com, what he need a IP address of cisco.com. So what he did, he has forwarded the DNS query to us DNS server. This is your local DNS server. This is your local DNS server. You send a standard DNS query. And if you want to go into this packet, let me go into this packet. You can see they are using UDP right now, and destination port is 53, which means they works on 53, right? DNS works on 53. Now you can go here and you can check. This is the recursive desired. It's a recursive DNS query. You can see recursion flag set 1, which means it's a recursive query. question 1. And what he's asking cisco.com, type A, name is this cisco.com. He's asking like who is having this cisco.com IP address. Simply he has just did the query to cisco.com. Like he just want to know what is the IP address of cisco.com. In one time it has just failed this query. Now he has sent the next query. It is also a recursive query. Is asking the cisco.com. Click on this one. A standard DNS query, a standard DNS query, a standard DNS query, right? You can see he has sent multiple DNS queries for cisco.com, right? And after that he has just get the DNS query response. Cisco.com IP address is this. In answer you can go cisco.com IP address is this. This is the IP address cisco.com. Now look for this query. You can go into UDP and look for the packet length is 35. This is the length. Source port is 54182. Right? Now you can go into this capture. Query coming from 20.1.1.200. Five four one eight two. This is the correct packet we are looking for, right? And this is the exact query for cisco.com. Now this is the standard query response for cisco.com. He has sent the response. This is the IP address, right? Now you can go here into this particular capture and look for this port number 54182. I'll go here and I'll look for this is the standard query 10.1.1.220 is communicating with this cisco.com, right? So what I will do, I'll just 10.20.1.1.200 is sending the message to this, sir, this, right? And go to into UDP. Port number is 54182. This is the correct port. So guys, what we have asked, he has received the query from this PC towards the local DNS server, because this 10.1.1.220 is the local DNS server IP address, right? Now this local DNS server, again we have received the query. Now you can see 10.1.1.220 is communicating with the public DNS server, and he's asking what is the cisco.com IP address. He's also communicating with 4.2.2.2, and he's asking what is the cisco.com IP address. And from this, he got the IP address of facebook.com is this, right? And after that, you can see 10.1.1.220 has sent the DNS response to 20.1.1.200, and he's asking a standard query response is for cisco.com is this. And after that, you can see that's how they did the communication here, guys. Now 20.1.1.200 is communicating on cisco.com. They are sending ICMP ping request. That's how they are doing the communication, guys. Now why we are not able to see here root DNS server? Because you know, in my DNS server I have configured these two IP address. So like if my local DNS server is not having the details, then it can able to communicate with the public DNS server. So my local DNS server is trying to communicate with these 8.8.8 and 4.2.2. These are the public DNS server. And if you will look for this request initiated by 10.1.1.220, which is a DNS local DNS server communicating with the public DNS server. And if you will look for this DNS request, you can go into the flag. Cisco.com, he has sent this request over this one, and he is also sending the recursive query. So what I can do, if I'll go here If I'll go into my tools, I'll look for DNS. I'll go here, configure, not like that. I'll go here, properties, forwarders, because you know, I have removed the forwarder and I'm using this local forwarder. So I'll go here because it will forward the request to these forwarder if he is not able to find the details. In advanced root hints, these are the root DNS server. So I have removed that detail, forwarded details. Now I'll click on OK, click on OK. Let me just double check. I don't have any forwarder, means now it will do the lookup towards the public DNS servers. Okay. So I'll go here into my Wireshark captures. Okay, now I'll go here into this PC again, and this time what I want to do the ping to, let me just try to do some more website. Let's suppose this time I will target towards hdfcbank.com. HDFC sir, what is the, maybe I'm not sure I'm putting the correct URL. So let me just do ping to hdfcbank.com. Ping is working, so URL is fine. I'll do the again hdfcbank.com. I will start the captures. And I can able to see all the details on this packet itself. Let me do the lookup for facebook.com. See, query for facebook.com has been received. Again, type facebook.com. Again, facebook.com. So now my looks like I'm getting the DNS queries, right? Towards local DNS, and local DNS server is not forwarding these queries anywhere, right? So what I can do, let me go here, go into tools, DNS server again. These are the root hint. These are the root servers. This is advanced forwarders. Number of seconds before forward query timeout. The server FQDN will not available if approved resource lookup or not configured. Without forwarder, it is not working. I want it so they can basically start communicating with these. Let me go into this one. Let me put that detail. Go here into forwarder. Click on OK. This is manual. This is usually a temporary error. Still getting the error. It is trying to validate this. Okay, it's not happening. Okay. I'm not sure why it is not basically sending these queries to the. Let me just see if we have anything else. Without for root hints, it is not able to come. It is not communicating using these root hints actually. It should communicate. Because if I will configure the forwarder, then it will basically do the communication. It will start basically communicating with that forwarder. Like 8.8.8.8. Now we cannot able to see like it is sending the query towards your root DNS server and other things, right? And I wanted to show you that capture. That's why I don't wanted to put that detail. See, it is okay, right? And let me go into this root hint, edit. Let me put this IPv6 address, click on OK, forwarder, edit. Let's see, validation is happening, what it can do. It is okay, but this thing is not able to validate it properly. It's IPv6. Okay, so guys, I think I can able to explain till here only, because this local DNS server somehow is not configured properly, and I'm not from this background of like this AD server and all. Okay, so that's how the things are happening. Whatever the things I've explained, this is how basically things used to happen, because this forwarder somehow I'm not able to basically configure properly. So like directly it is going to local DNS server, right? Not going to but these root hints. These are the 13 root servers actually. Okay, cool. So guys, let me just see. These are the things which I wanted to explain with regards to DNS. Now remaining thing like how to configure DNS server, all these things we will cover into your next lecture. Like what is DNS zone, what is DNS record, all this information I will explain in your next lecture. Take care guys, bye.